We discovered TV.
Liam.
What?
Okay, so one thing that I kind of designed for today is I want you to see how lists and arrays work. A lot of the times they're going to be interchangeable. And for most of the work that we do in here, you'll be able to use a list because you're going to put data into it specifically. So the data in the list is already going to be of a certain type. Now, if you get to a point where you have to make sure that you're very specific about the type, that's where you can use arrays, because you can tell an array, make this a specific type of data. Like, so for example, in Python, there's two types of numbers, integers and floats. Integers are like your 1, 2, 3, 4. Your floats have a decimal point, so that's all that means. If you see a number with a decimal point, that's a float in the coding language. But, you know, for example, going down a couple of lines, let's say I put in, I'm going to use numbers from the lab. So I don't know. Variables can be whatever you want them to be. I called this one list A. And so A means nothing to Python. So I set it equal to something. Now, I made this general. You could make your array, you could name your array Jackass if you want. It doesn't matter.
Thank you.
You could. It's really up to you what you name your array. Now, the great thing about spiders, you see the little X next to the 4? That means there's a syntax there. It means I've typed something wrong. Python can't do anything with that. So it's going to try to warn you that something's wrong before you try to run it.
Why is yours green?
I changed all my settings.
Okay.
You can go into
So mine's not
preferences.
green, that's something.
Yeah, no, you can go into preferences and, you know, change it around and personalize it. But like if I ran that, look, I get an error. Okay, well, Python doesn't know what A is. So what I'm going to do is I'm going to go ahead and use square brackets. And then I'm just going to put in what? 1.17. Now, in a list, you want to use commas to separate everything. Now, just so for me, I can read it easier if I put a comma and then a space. For Python, it doesn't matter. You can just do number, comma, number, comma. It doesn't matter. You can put the spaces in. Python can handle either. Okay, now. Now, let's say, you know, this is like a set of data. Let's say I wanted the mean value of this. Well, I don't think Python.
Do you have to skip one every time?
No, you don't have to. You want to design this in a way so that you can go back and read it and it looks neat. So I'm just going to call this B. So I need to make it a variable. Tell it to do the mean average. The mean value of those numbers in list A. Then you have the print function, which print is pretty self-explanatory. Yeah, but there's a problem. You notice it's giving me that little red X. So you see how it tells me, the printout says, Python's like, I don't know what that is. What is the mean? Okay, well, that's why I started the coding lab with libraries. This is what libraries do. They have all these definitions in them. So you just need to know which library you want. So for example, and the way you bring in a library is you import. I'm going to import statistics. Now, I could just leave it like this. But then every time I use it, I'm going to have to type out statistics. And what you do is you'll call the library, you'll put a dot, and then the calculation you want it to do. So now it'll do it. It prints out the mean value. But I don't want to type statistics every time. That's why I rename it as an alias. I just call it ST. That way, all I have to do is use ST. Makes the typing a lot less. And again, that alias, I just picked ST because to me, I remember statistics. You could call it cat, it doesn't matter. So that's what we mean, that's what I mean when I say bring in the libraries. Okay, so let's I'm going to erase this for a moment. I want to show you a little bit about what's in the actual coding lab. I'm going to make two more arrays. We'll make array little lists. These aren't technically arrays yet. Let's see, 1, 2, 3, 4. Let's see. Let's do a combination. 3.4, there's a float. 4, there's an integer. And a float. Okay, now. For lists, we have a command called type. It can tell you what's it can tell you what's in the list. So now we're going to try to wrap our minds around a loop. Okay. I want the loop to tell me to pick one of my lists and tell me what the data type is at each individual index. Now, if you once you read through here, you notice that Python index is starting at 0. So if you were to pick a specific index, you see how I have 1, 2, 3 elements in there? Well, in Python, that's 0, 1, and 2. You always start at 0. Even though there's 3 elements, it's 0, 1, and 2. So if I ask for C3, it's going to tell me no, because it doesn't have a 3. It has 0, 1, and 2. This one has 0, 1, 2, 3. And so you're kind of getting used to the idea of indexes. You see them on the sig, like when we do sums and whatnot. So it's like if I told it, just to illustrate, print, so I'm going to tell it list C, square brackets, index 3. Okay, so pick the third element out of the list. Well, it can't do that because that's outside the range of the list. Okay, well, pick element 1. So it prints out a 4. So that's how you think about indexing in a list. But let's see if we can figure out what type of data is in this list. So I think the best loop to start with is a for loop. Now, one of the great things is when you get the command right, Spider will change the color of the command to whatever you have it set at. So you know, oh, okay, so that's valid. That works. Now, this is not going to make sense right away, so I would just copy the syntax. To be able to index a list in Python, you have to use the range and the length command. So the range of the entire list, the length, then it needs to know the length of the list and the way it looks. So I'm just going to say for index I, and again, it doesn't matter. You can call it X, you can call it N, you can do anything. For index I in the entire range, for the length C, oops, that's a capital C. Now, in a loop, you want to make sure you end these first lines with colons. Now, Spider's going to automatically do it for you because then after the colon, you get an indent, and everything at that indented level is inside the loop. Let me try to make this a little bigger. Can I do it? There. Come on. There you go. That helps? Okay, so now we're going to go through this whole loop and we're going to talk about its structure. So I started with for every single index I for over the entire range and length of list C, I'm just going to make another variable that I'm going to call IMP for because I'm like that means each input, each element. You could again the variable is whatever you want to make it. gonna equal, and then there's a command called type. Type, and then I want you to tell me what type of data each index of list C is. And that's what the I is. So the reason for the loop, and then we'll go ahead and tell it to print input now. And then I'm gonna put one outside the loop. You don't have to go down two, but you notice how I went back from the indent? Now I'm outside of the loop, so I'm gonna tell it. Now this print here, this is just kind of like a housekeeping thing. It tells Python to leave a blank line. Let's talk about what it's gonna do here. So we have our list C. We see it has indexes 0, 1, and 2. So that's I. And that I will become 0, 1, and 2. The reason for the loop is the first thing it's going to do is it's going to go in and it's going to say, okay, C0, 3.4. What type of data is that? But it's not done yet. That's why I told it the range and the length of C. I want it to do the whole list. So until it finishes each element in this list, it's going to keep going back and doing it over again. And so then it's going to go back and say, okay, well, I'm going to grab index 1. I'm going to define that. I'm going to tell you what type it is and print that out. Then I'm going to go back in and grab index 2, tell you what type it is and print that out. And so once it's finished the whole list, then the loop will terminate because it's finished its job. So if you tell it to run this, you notice now how it told me that each individual element in that list, I have a float, an integer, and a float. And this is where sometimes arrays can become important because a lot of times, and we'll get to that, but a lot of times arrays will automatically adjust the data type for you. But you can also tell an array specific, like if I just put in 1, 2, 3, 4, and I told the array data type float, it would automatically change all of them to floating point numbers. And one of the problems is like, let's say you're doing some statistics and you need to do one of those sums where you need to grab the number, so you're looking at a loop where you go in the list, grab the number, go in the list, grab the number. You're adding them all together, you can go through the list. Well, one of the things Python will do is a lot of the times if they're not floating point numbers, it'll give you an error saying this list cannot be indexed. Which means, so it means like, this is just a list. Your indexing is usually for numbers, so I'm getting confused. So it's usually nice to make sure everything is going to be in, I think floating point numbers is a good default to go to, so that just means a decimal point. Versus, let's turn one of these into an array. We'll just do the same one. Now, you're going to see it give me another error. So I'm going to say, I'm going to make another, this time I'm going to make it an array D. So for your array, you're going to do, so this command is going to have your curved, like, what do you call those? Your parentheses. Then inside of that, your array is going to go in square brackets. We're going to do the same set of numbers. 3.4, 4, 1.2. Okay. Now, but you notice I still have an error there. It doesn't like this. It's not defined. So another reason for one of the most popular libraries you will use for science, NumPy. So I'm just going to bring in another library that's going to do this for me. And so an array is a NumPy element. So I'm just going to put NumPy on the front of array, and now it works. Now, for arrays, the loop looks a little different, and we'll talk about it. The best thing to do is just to do a number of these loops, and you can start to see how the different syntax. They can give you the same answer, but you need different syntax for different objects. Okay, so we're going to do another for loop. I'm going to say for x in D. I'm just gonna call this one input 2. Now, you notice how for the list we use the command type. For an array, you want to use D type. Yeah, I wish we could get that higher on the wall, but we really can't. Okay. So D type. Then I'm going to tell this to print input 2. And this will illustrate inside and outside the loop. Okay, now, well, you're in luck because you notice what the array did. You notice how when it's just a list, I get a float, integer float. When I put it in an array, float, float, float. The array,
Mine's not. Oh, it's through the 16. Wrong. There was no point of that.
your settings should be fine.
But you see how you.
I don't know why there's an X
The
that
number.
you might not have that or have that library.
I don't know, it's like-
No, we'll work on that in a minute.
No, that's the software that they said.
Why is it?
So we use
You-
the same
you don't-
computation and then assembly, like.
Download Anaconda, okay, you should have all the libraries.
You're talking
Okay.
about-
Right there.
So. So I think it would.
I could.
And
control
we
it.
like read it.
You can get out.
I think this is just.
You lost.
Acting into your.
Most people don't never even.
Oh, it's such nice. If it's so.
Okay, so we're gonna try that. If not, I'll come back later.
Oh, so then it says.
Yes, I did 90.
I'll come back later, we'll work on
Like
it.
for the whole.
So.
Because I wanna get through this.
Centimeters, 300. This is insane.
Now,
Yeah.
after this, I'm gonna go to some statistics and show you how you can make your lab easier.
Zero.
But this gives you an insight into what's going on in the coding lab. Notice the 2 loops. First off, you notice how the print here inside the loop prints each time the loop repeats. Okay? The print that's indented inside the loop repeats each time the loop repeats. The print that's outside the loop, you notice gives a blank line, but only does it once. So this print here will not iterate every time the loop repeats. This loop will repeat, then it'll read this. Then it's gonna go to the next, so it reads this, gets that definition, goes to the next loop. And so Python's gonna read things in order like that, but you notice the array turned everything into a float. However, I'm gonna put in an array of only floats. So I'm gonna call this. I'm gonna make an array. 1, 2, 3, 4. Then I'm going to do for Y and E. Input 3. Y dot D type, tell me the type of input of element. Input 3. And if we tell it to run. Uh-oh, I did something wrong. Oh, hang on, I know what I did. Your array needs square brackets. There we go. Now, notice how inside this array, it tells me that each of those numbers is an integer. That could be a problem for mathematics in Python. So here's one of the reasons an array is great. Now, look at my array E. If I now put a comma in there, and I tell it D type equals float, that means I've just told the array to change everything to a floating point number. And if I run it again, now they're all floats. And what if I tell it to, now here's something else you can do with print. So you notice how I'm telling it to print out what type of data it is. I can also tell it, tell it to print Y each time. So now, you notice how I changed the print. You notice how this loop is going to grab each index Y in the array. It's going to grab the 1, 2, 3, and 4. It's going to go through the loop. And what it's going to do is it's going to print out the input at each index, which are the Y's. And then I define input free is telling me what type of data it is. So it's going to, I put Y, comma, and then my next variable. So inside a print statement, if you use commas, you can put in multiple variables and have it print them all out. So this time it prints out, and you notice I only put in 1, 2, 3, 4. But I told the array this is D type, the data type is float, so it changed all into 1.0, 2.0, 3.0, 4.0. So that should really help you like looking through the rest of that lab. I do want to go over real quick some things that could make today easier. So I'm just going to open up a new tab here.
What?
And so I'm going to bring in statistics again. Bring in NumPy. Then I'm going to use data from your pre-lab. Okay.
Yeah.
So this is just one set of data from your program. Now you notice that if you do the math by hand, it can take a while. But what if I wanted the mean value for these numbers? Okay, so the first thing I need to do is I'm going to make a variable. And I'm going to go into my statistics library, mean value of A. So it's going to take all those numbers and give you the mean value. Okay, so you can now watch this. You can also put strings inside of print. And when I mean a string, it's just a list of characters. So you look at them as words. And so what this is going to do when it prints, it's going to say mean, colon, and then it's going to print out the number. So it's giving you a label for what you're printing. So I put in the string, I have to put it in quotation marks. It doesn't matter if they're double or single quotation marks. Then I'm going to put, again, I put my comma and tell it to print A1. So you notice it gave me the mean value of all those. However, you notice Python prints out a lot of numbers. So here's what we're going to do. I'm going to make a new variable. Okay, so A1 formatted. Okay, just kind of watch what I do here. You get used to this after a while. This is kind of like learning to speak a new language at this little point. You just kind of have to get used to it. So I'm going to do quotations, curly brackets. And then I'm going to tell it for the whole number, colon, dot 4f. I'm going to go outside of that, dot format, the variable A1. So what I'm doing is I'm formatting the number it's going to print out. And watch what it does. So I'm going to print out both numbers. So look at what it did. That format, what did it do?
Yeah, I'm still.
So we're going to do that. So there are two. This format did 4 decimal places. So your dot number F gives you decimal places. Dot number G gives you significant figures. So if you said dot 2F, you'd only have 2 decimal places. You said dot 10F, you'd have 10 decimal places. Now, let's say you wanted this down to 2 significant figures. You do dot 2G, then you dot format the number. So you can format your numbers. So there, it calculated a mean value. Let's look at the one that's probably the biggest to type in, that's probably the biggest to do by hand. Which one do you think is the biggest to do by hand? Standard deviation, all right. Let's make, I'm gonna leave a blank line. Just work nicer. Okay, now I'm gonna make a variable A2, and then I have this nice little function, statistics.stdev. So again, this is why I like Python. When you look at stdev, you know what it means. It's not like C++, where it's like, it's like hashtag underscore S157. Like so we're gonna do the standard deviation of A, okay?
I knew it.
I know it's gonna come out with a lot of numbers, so I'm gonna format this. To 2, so your G, your F is decimal places, your G is significant figures. So I'm gonna format this to two significant figures. The entire number, dot 2 G in my curly brackets, go outside, format. Nope, it's supposed to be dot format. Format, A2, sorry. Now let's make it printed out really nice. My string.
Don't like this.
Deviation. A2G. So I'm gonna go ahead and get rid of the A1 here since you know what it does. Uh-oh, look, now I have the standard deviation of that entire list.
Oh, yeah.
So if you get used to some of these real basic codes in Python, you can do your math real fast. Now, that's all we're gonna do for today. I'm gonna go ahead and finish out the statistics calculation, so you can come up and look at them if you want to. But here's the little deal. Python can do everything we're gonna do this semester. It can do vectors, it can do vector components. You understand the math of how to put it in there. Next week, we're gonna continue with the mathematics, and I'm gonna show you how to put in just straight math into Python. And then use some of these, and we're gonna compare doing the math to these commands, and you're gonna see how they come out the same. But when exams come along, you're gonna be doing a lot of vectors, especially next semester with fields. If you can write a Python program that will solve the entire exam for you, you can use it on the exam. That's my little way. If you can write one that will solve all your vectors and do it all for you, you can use it on the exam, put in the numbers, hit enter, go have a good day. Yeah. I think it's gonna be.
Lexic and she told me 68 for number 3. So number 3 is different. I am very much numbers dyslexic.
Oh.
Like I do these people's amounts of that's very soon.
And then for your format.
Oh, do the third, just change the third and fourth. Oh,
Right up against.
yeah, the third and fourth. The fourth is our new
There we
one.
go.
Awesome, that one's right.
And-
Oh, I read the numbers in this time. Okay, that one lines up perfectly on that one. Dyslexic. 8. Excuses.
Good with that. Format and your, let's see, what is that?
Okay.
Oh, that's the mean of these. We're formatting.
Oh.
Yeah, we do.
Where's pretending this is?
I did it.
Oh, thank you.
Mhm. So you guys go ahead and work on the lab. I'm gonna finish off the statistical calculations and you can see them if you want to.
It's 68,
86.
yeah, 86.
Sorry.
It's me.
I just got.
0.65. Oh, yeah, not for you. I sent the coding picture. I took pictures of the code.
What are you doing it into, guys?
Like, do it on shop. Okay.
Also, let's go.
Yeah.
It's probably good, if you guys just mark it.
We literally just drew it on the table.
Yeah, so just get a mark on the table, cause it'll face off, and then we just drag it over and put it in there.
I think Dylan knows how to do it. It's supposed to be over now.
So now we need the meat of each.
He's fine.
Just put the meat inside.
Or just do the meat of just like,
Yeah, of
Just
one
the
of them.
of just one of them.
Yeah, we'll send the
Standard
labels.
deviation.
Hey,
Well, that's-
Should we do it
Meat.
instead? We just repeat
Okay.
this.
I mean, we do need the standard.
450.3.
then, does it matter if we do the, like, mean standard deviation?
And then a standard deviation,
No, I think meters is easier, but just movement of a decimal.
Yeah.
Yeah, it doesn't matter.
a 3 is equal to,
Instead of these.
I'm gonna do that.
is there a standard error?
That's mostly accurate data because it has the lowest amount of standard error. But also helps at the, then when you go to number 3.
I'm sorry.
Well, so, okay. So there's another calculation we did
Was
last.
it 450.40?
Also about active. Notice how I gave you an actual value?
No.
Yeah.
Before.
What do you mean actual value? Yeah, you mean that
Standard deviation is 0.38.
percent error. Try calculating the percent error, because here's what you're gonna find. Student two is gonna have a noticeable percent error, a very low standard error within within their own data set. What does that
One
mean?
more.
What do you lab? It means something that's in the lab. Systematic error.
Yeah.
Oh, yeah,
Yeah, so the standard deviation is gonna be the same.
So you say that's standard.
And now we're being the 70s.
Within a data set, but this doesn't necessarily be accurate to the actual value. But but that means that you were very accurate in your own work.
0.38.
You just, this student just had some kind of systematic error, that was destroying the search.
Do we have to? Or find,
No, no, you just said error. You just tell me, because you did it last week.
It's just the standard deviation. Divided by the square root of the 5.
No, that was just.
So we're gonna do what?
64. Yeah, so we want to solve for just the right now.
68.45 hours.
I'm gonna do it in meters.
Yeah, like I go
Let's see
into those nuances and change this whole, because like I have a very, I have a color palette that I like. And so I change font, I change color palette.
For the.
My entire color palette is cyberpunk, so.
I love that. Okay, so now we just do that. Okay, that. So that. This is a thing, survey. Yeah, the area is a beginner. This one says verdi.
Yeah.
Or plus.
How would we do standard deviation, right? In Python,
No.
Oh,
Do you want it?
so, here, let me type these in, because I have it up there already. So what I did was I put in the equation. You notice how for one of them I did the standard deviation? Then I did that over the square root of n.
Yeah.
So I just, so what I did, and that's what
Like when you
link.
do standard deviation, you do the.
So the
You do the add.
Yeah, it's going to be the link this
Okay,
array.
yeah.
Yeah, you notice when you do the link command, it'll give you the number 4, that array. How long is this array? Well, there's 4 inputs there. Okay,
Number for
so you see how I have 1, 2, 3, 4 numbers?
Yeah.
You see this command length? L-E-N? It's hard to see with the lights.
Oh, there, yeah, okay.
Yeah.
Your hand's just like.
So I make a variable n to match my equation. Here, try to-
That was like what we need to be. Things like standard deviation, what we need, what we do.
I make a variable n to
And he
match.
goes,
Match the.
What I say now.
Yeah, to match the
Yeah, what?
standard
Yes,
error
exactly.
equation.
Okay.
And then link, and I just L in.
I don't know how
Square root,
many
and
people
then
got
take the
different
square root.
measurements.
So look here, this is what we're doing.
And that's what's gonna be so much longer to
Another variable. I tell them,
Yeah.
hey, two.
I also know special.
Divided.
We need 60.
No, it's like four one.
No,
So look at the syntax.
I got 100.
So I want
I got
that square root, I want that square root.
Okay, centimeters. That's
First centimeters.
Yeah, first, that's centimeters.
I do np dot strp. Square root being called from the NumPy library. And then inside the.
Here, you didn't keep my pencil.
Next to square root.
Okay, there you go.
This guy.
All I have is-
Play.
Mhm.
But isn't it,
nah, I didn't mark it with a Sharpie.
that's not, I'm thinking of all these.
No, the length is, so the length is 4.
Oh,
So you see you have 4 inputs?
I'm doing like for that.
Oh, you have 5, yes.
Okay.
So it's just
It's
gonna,
like
it's just gonna
three.
count up.
Oh, the length is how many?
And then
Yeah.
Got it. Okay, so.
And that's what you have to have for the error.
Okay.
And so can you see the standard error equation there?
Not the goal,
See the same.
not.
And then I just formatted the.
Is that like how many?
Right in there.
He is significant figures. F is decimal places, G is significant
Minus
figures.
me.
Sometimes I just think.
So then I just go.
Add that together, and then divide by.
How you know this? It's like little.
Well, it takes practice.
And
Oh.
then square.
He has a little bit of easy eye, he's that has it too, so he calls it his
Here we
rock eye. And so it's like you have something not like you're straight or something, they'll be like something. Your Robbie eye.
That's telling us that's formatted.
Others, but it's not that bad right now. So it's really have to be like looking and making straight eye contact with him to be able to tell. You really have to be staring at her. But he sees that, you can tell, he sees that, there's something wrong, so you have like, don't look at lazy eyes, so sorry. No, you're okay.
Right.
And then comma. And then your formatted variable.
Okay.
Oh, could you put plus? Oh, right, see what you get. There it is.
Good, thank you. Alright, guys, we got it.
I see the bottom.
No, I'm
Alright.
working on percent error with the actual value, so I put V as my actual value.
Right.
Okay, presentation.
No, you're 0.7 again.
That we had.
What?
Is V like the mean of the A unit?
He's putting it on.
Okay.
Well, I just, that's just the direction I gave it, but see in the pre-lab, your actual value is 1.4715. Yeah, so you use that for percent error.
So then we just have to look at our range. We
Then
just
add
have
them all
to figure out
together.
how many of your measures are like when people fall in.
And then you
extra
can.
height.
Yeah,
So
you're saying.
we'll have to see how many fall within this range here.
The lab.
So 1, 2, 3, 4.
Alright.
All of that.
Advantage.
0.74. Standard deviation is 0.055.
Yeah, no.
0.055.
0.055. No, the standard deviation should be fine. And then standard error is 0.6.
Oh, okay.
Yeah, that is something that
Okay.
most people drop coding.
We do
Is
have,
little bitty
trying to find the area.
And these are all the same because it's the average of all of these, right?
What is-
Yeah, yes, okay.
What's the V?
That is, I just called it V because it's that actual value that's in the lab there.
Okay.
I'm doing percent error from the actual value.
Yeah.
No.
Oh,
We didn't give us an actual value, it's just. Probably could just row 1 and then just drop it.
Okay, the standard deviation.
Oh, no. Sorry.
Nope, you're okay. Are you just trying this? Yeah.
We said run, I think to just.
And then same for the area, you would just do the mean of each.
The mean times each mean.
Yeah. That's what I was saying, like, you just use the mean as your. That's what I was thinking.
Would you think that it would just be the millions times? Times the other.
I was gonna say, we just say, that's it, saying here, oh yeah, to calculate the area, you use your new. Okay, so yeah, so just times the two.
So what's our mean in the first one?
Oh, first one, 450, 0.34
Yeah.
times it
That's the
by.
thing about this. When you get all this in there to do all your statistical calculations, you see the array at the top with the numbers, you just have to replace those numbers and hit run again, and it'll do the next set of numbers. So,
Okay.
That's a big.
yeah, like, once you get all, so your little play button there. That one program, once you get all this in there and do calculations properly. You can,
Then
all
we
you
just
can
do
do is
the
change these numbers.
percent, or the air, standard air, sorry.
Yep.
Of that.
But how do
Yes.
we find out?
Of the area.
Now I'm missing it. I don't know. I had